Hello, welcome to Math with Beth, and we are going to look at base N exponential growth problems. These are a specific type of exponential growth. So if you're just looking for the regular type with E, I have a video on uninhibited growth because that's what that one is. But this is for specifically if it's something like this. If a quantity increases n-fold over a fixed period of time, that means if they tell you after a certain amount of time, it doubles, it triples, something like that. Then the quantity is given by this. P of O is still the initial amount, and then N is that N fold. So if it doubles, N would be 2. If it triples, N would be 3. Little t over t means the little t is what we always think, the amount of time to do whatever you're talking about. But this is the amount of time it took to double, to triple, to do whatever the n is. So let me show you an example. The number of users for a new app doubles. So that means n is 2 every 3 months. So that's the big T. Assume there were 1,000 users when the app started. So that is the initial amount. So find an exponential function with base 2 that gives the number P of t users after t months. Just means set up the equation with 1,000 being the starting amount, 2 being the base because of the fact that they told us it doubled after 3 months, and the 3 would go there. That's it. That's our equation. Now it's going to ask us to find the exponential function in base E that would give the same thing. We don't need to think of a whole new equation. We can just manipulate the one we already have. So if we want to basically change that 2 into an E, I'm going to leave the 1,000 alone, and I'm going to replace the 2 with E to the ln2, because that is the same thing as 2, but it just allows me to bring the E into the problem, right? Because E and ln wipe each other out. So that's just a fancy way of writing 2 because they wanted E in the problem. So everything else is still there. But now I can make this a little nicer because I know I can multiply these, which really means I can do the ln2 divided by the 3, since ln2 is on top and 3 is on the bottom. So if I find out what that is, ln2 divided by 3, I can rewrite the problem with just a decimal here. And so if they asked me what the rate is, what the K is, I could now tell them because I found out what the K is. So these are just 2 different equations that would get you the same result depending on what you plugged in. So for C, what is the number of user accounts after 12 months? I'm going to show you and use both equations and plug in 12 and see what we get. So for the original equation, the 12 would go there. For our equation with the E, I would plug it in there. So because of the decimals, sorry, that's my 12. We might not get the exact answer, but it should be pretty darn close. So if you put this in the calculator, you would get 16,000. If you put this in the calculator, you get 16,000 and a few cents. So basically the same thing. But then when they're asking us which equation was easier to use, it would definitely be this one, because 12 over 3 is really 4. 2 to the 4th power is just 16, and 16 times 1,000 is 16,000. So I could actually have done this one without a calculator at all. This one, no chance. So the one with base 2 was easier to use in this problem, but it depends on what you're doing. So I'll show you another example where that might not be the case. If Bella invested 15,000 in a high yield hedge fund, and after 14 years, the original investment tripled. So this is going to be the N. This is going to be the big T. Find exponential functions using base 3 and base E. So they want us to do both of them again. That give the value A at the account after T years. So that just means the name of our formula will be A of T. So we're going to do 1 with the base 3 because of the tripled, and then we're going to change it into E again. What is the yearly % growth rate of the fund? Which was easier to use? Okay, well, first let's set these up. So 15,000 is our starting amount. So that's going to go in the front for both of them. In this one, we're going to use the 3 for the tripling and the 14 for the 14 years it took to triple. And then over here, I'm now just going to replace the 3 with e to the ln3, because again, those are the same. They just look different. But now I have one with base 3 and one with base e, just like they said. This one you can't make much nicer. Remember, you cannot do the 15,000 times the 3 right now because 3 has an exponent. But over here, I can combine these, which basically just means ln3 divided by 14. So let's see what I get when I do that. And that is now my exponent with the t. So here are my two equations. Now let's just remind what they were asking. What is the yearly percent growth rate of the fund? Well, in this form, we can tell that just by looking right here. So we know the growth rate, which they usually call K, is 0.0785, which really means 7.85%. So which equation was easier for that? The one in this form with the E. So the base E was easier to tell the growth rate. Okay, let's try one more. After its salt mine closed, Nackville lost 15% of its population every 4 years. Find an exponential function that gives the population P of Nackville after T years. Okay, with percents, that's the same as saying it like doubled. It's just that you're going to put the percent in as that base. The only trick here, though, besides that, is the fact that they said it lost 15%. So first of all, we don't know the initial amount, so I'm just going to call that P sub O. The number here should be how much it's growing. So if it lost 15%, what is really happening every 4 years is that we only have 85% left. So that's the trick, that instead of putting the 0.15 here like you probably want to, you really put 0.85 because that's what would be left if 15% went away. So that's definitely a trick. Everything else is the same though. Find an exponential function that gives this after T years. So this is it. After 8 years, what percent of population has been lost? So again, we got to be careful at the end to explain what has been lost. But first, we can use this to see what would be left. I mean, what we would still have, yeah. So P0, we still don't know, but we can still find out what percent is left when we plug in the 8 for T and just basically figure out what this is. So 0.85 raised to the second power would be 0.7225. So that basically means 72%, 0.25. But again, this is how much is still there. So if they want to know what's lost, I need to take that away from 1. Or if you'd already made it a percent, you would take the percent away from 100. Either way. So as a decimal, you're taking it away from 1 to see what would be left. As a percent, you're taking it away from the 100% to see what would be left. Either way, you would eventually end up with 27.75% left. So this one was definitely the trickiest one because of the fact that they kept talking about how much was lost or how much was left, and we had to figure that out. But hopefully the general equation, not so bad. If you need more examples or have any questions, please let me know. Thank you for watching. Bye.